All right, welcome to the lecture covering 9.1 Solving Trigonometric Equations with Identities. So we have spent the last 3 chapters building up to being able to solve trigonometric equations, and we're going to get our first taste of it tonight, not so much solving equations, but more so just how to switch between different forms of the identities and build up or rather remember our algebraic skills in working with these types of things. So we'll go ahead and move forward into this. Okay, so the first thing that we encounter in this section is a reminder of our Pythagorean identities. And I'm just going to show you first how we can move between different forms of it. And that sine squared plus cosine squared equals 1, that comes directly from the Pythagorean theorem. And then we get the other 2 versions of it by dividing by either sine squared theta the entire way through or cosine squared theta the entire way through. And then we're actually going to take a moment to prove the other 2 that we come up with. So we'll start with our Pythagorean identities gotten from the Pythagorean theorem itself, which is x squared plus y squared equals 1 when we're dealing with the unit circle. So if I come in here, let me grab my pen and get that going. If I come into that first one, sine squared theta plus cosine squared theta equals 1, and I divide both sides of the equation by sine squared theta. That means this gets divided, sine squared theta, and this gets divided, sine squared theta. These thetas look like zeros. Let me try to fix those. There we go. Okay, so sine squared theta divided by sine squared theta, well, anything divided by itself is just 1. And I know that when I have, well, I'll go ahead and rewrite this. So plus, welcome Ken, let me get you checked in real quick. We just started, so you're good to go. I'm just showing Pythagorean identities, which we've already studied. So cosine squared theta divided by sine squared theta equals 1 over sine squared theta. Okay, so if we look at that second term there, if you remember way back when we first started studying the unit circle and special triangles, remember that cosine over sine is actually cotangent. So this whole thing right here, since I have cosine squared over sine, or cosine squared theta over sine squared theta, that whole term right there turns into cotangent squared theta. So I have 1 plus cotangent squared theta equals, okay, well, 1 over sine is the equivalent of cosecant. That's the reciprocal sine is the cosecant. So that whole term right there turns into cosecant squared theta. So we have this other form of the same Pythagorean identity, just in a different form here. Now let's see what happens when we divide everything by cosine squared theta. And we know we like to have things in sine and cosine because those are our x and our y coordinates on our unit circle there. Our x coordinate is equivalent to cosine, our y coordinate is sine. So here we end up with sine squared theta divided by cosine squared theta plus Well, cosine squared theta divided by sine squared theta is just, divided by cosine squared theta is just 1. And then we have reciprocal cosine. I'll just rewrite it this time, 1 over cosine squared theta. All right, so if we come back, sine over cosine, that's the equivalent of tangent. So here we have tangent squared theta. And here, 1 over cosine, that's reciprocal cosine, which is secant. So that is secant squared theta. So we end up with another form of this Pythagorean identity. Tangent squared theta plus 1 equals secant squared theta. Okay, so these are just different forms of the same thing. Now, your book takes you through the process of proving those, so I thought it was a good idea to follow suit there. So what we're going to try to do is start out with 1 plus the cotangent squared of theta and see if we can work with that in its form there and get it looking like cosecant squared theta. Well, that would be the same thing as having 1 plus, well, we know the cotangent is cosine over sine. Tangent is sine over cosine. Cotangent is the reciprocal of it. So this is the same, our cotangent, let me get a different color here. Let me choose green. That'd be good. Our cotangent squared theta, if I want to write that in an equivalent form, I can write that as cosine squared theta over sine squared theta. Now, to add these two things together, I've got to have a common denominator. So I'm going to multiply this 1 by sine squared theta over sine squared theta. And so now I have sine squared theta plus cosine squared theta over sine squared theta, and that's over sine squared theta as well. So now I have a common denominator, so it's perfectly acceptable for me to combine my numerators over my common denominator. And if I do that, I get sine squared theta plus cosine squared theta divided by sine squared theta. Okay, so the reason I wanted to prove these is because it's going to warm you up to the things that you have to be clever about. Here's your first clever point. If you look at that numerator, this entire numerator is equal to 1. Sine squared theta plus cosine squared theta. And you can have those terms flip-flopped, of course. It could be cosine squared theta plus sine squared theta, and that's all equal to 1. So I can replace that entire numerator with 1. So now I have 1 over sine squared theta. And I know 1 over sine, that's reciprocal sine, which is cosecant. It's squared, so this whole thing is equal to cosecant squared theta, which is exactly what we were trying to show that 1 plus the cotangent squared theta is equal to. Give me a green check if y'all are following me so far. Hey, Josh says yes. Kim says yes. Awesome. All right, so we're going to do the same thing with this other identity over here. We start out with 1 plus tangent squared theta. And I'm trying to write that in a new form to work it through and have it turn into secant squared theta. Well, tangent is sine over cosine, and this is tangent squared theta. So I'm going to try to rewrite that tangent squared theta. And I'm going to do that by writing it as sine squared theta over cosine squared theta. I need a common denominator again. I can't add those without having a common denominator, so I'm going to multiply by my clever form of 1, cosine squared theta over cosine squared theta. And now I have cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta. It's now legal for me to combine my numerators because I have a common denominator. So that leaves me with, let me move my little pen pad here out of the way, cosine squared theta plus sine squared theta divided by cosine squared theta. Once again, I now have that Pythagorean identity in the numerator that's just equal to 1. So I've got 1 over cosine squared theta. That is reciprocal cosine, which is secant. So I end up with secant squared theta. Same thing I started out with, or I was trying to show it was equal to. Okay, green check if you're ready to move forward. Now that we're in the groove of this. Excellent. All right. So this is just an informational page here, reminding us of stuff we already know. I included your unit circle in these notes just for you to refer to. Don't forget we have cats. So this is telling us which functions are positive in what quadrant. And if you don't remember that, you can go back and look at your notes. I believe that came from chapter 7, if I'm not mistaken. We have our even and our odd identities. Sine is an odd function because when I plug in negative theta, I get out the opposite sine function, so this is odd. Its reciprocal function, cosecant, is also odd. Cosine and secant, those are reciprocals of each other. They are both even functions because when you plug in the negative theta value, you get out what you started out with, just a regular old cosine function. So anytime you see the cosine of negative theta, you can actually replace that with just cosine theta. They're the same exact thing. So both of these are even functions. And then we have tangent and cotangent. You can see you get the opposite function out, so both of these are odd. Okay, and we have our reciprocal identities. I've been using that language since we were working on the last page, and we have our quotient identities as well that we've already used tonight. So this is just a jog your memory page here. Okay, so how do we go about taking a trigonometric identity and verifying that it's true? So you're going to work one side of the equation, just like I did on that first page of notes. It says it's usually better to start with the more complex side as it's easier to simplify than to build. You want to look for opportunities to factor expressions. You can square a binomial, and that's gonna create new terms for you to look at. And don't forget, adding fractions, you have to have those common denominators. You want to note which functions are in the final expression that you're trying to get to. So like with this particular one, you can see I'm going to try to get to sine theta. So anytime I have an opportunity to bring in sine, I'm going to do that because that's what I'm trying to move to. So that's what number 3 means there. And if the steps don't get you where you need to get, try converting everything into sine and cosine, because then we know we're in the realm that we like to work in, because we know what those quotient identities are and we know what our reciprocal identities are there. Okay, so these first two are pretty simple. We start here with tangent theta, cosine theta, and we're trying to see if we can get that equal to sine theta. Well, tangent is the same thing as sine theta over cosine theta. And I'm multiplying that with cosine theta. Remember, I want to try to move to everything looking like sine and cosine, because then I can work with it. And this is actually just about done. This is cosine over 1, and if I multiply straight across, I notice that I have a common factor in my numerator and denominator of cosine theta. And so I have already shown that I've gotten to the point of being at sine theta. Done. All right, let's look at this next one. And y'all just stop me if any of this is confusing to you. You know I don't mind stopping and explaining. Cosecant theta times cosine theta times tangent theta, we're going to try to show that all that business right there just equals 1. Pretty interesting. So I'm going to try to get all of these looking like sine and cosine. Well, cosecant is the equivalent of the reciprocal sine function. So this is the same thing as 1 over sine theta. And I'm going to multiply that with cosine. That's already in a form I like to work with. That's cosine over 1, just to be explicit. And tangent is sine over cosine. Sine theta over cosine theta. All right, since I'm multiplying all these, I can divide out common factors out of my numerator and denominator. So I've got cosine, cosine, sine, sine. And notice I'm just left with 1 over 1, which is the same thing as 1. Green check or red X. Green check, green check. Excellent. With all of these identities and verifying them, it's really, a lot of times it comes down to being clever and really knowing your factoring and knowing all of your identities and being able to freely move between different forms of them. And that just comes with practice. So tonight there aren't any more notes part really of the lesson. It's all just me working problems and showing you how to be clever with these things. Okay, so we're going to take the left-hand side here, 1 plus the sine of x times 1 minus the sine of negative x, and show that that's equivalent to cosine squared of x. So I start with 1 plus the sine of x times 1 plus the sine of negative x. Okay? So, I want to distribute here because I want to get this into terms that I can work with. So I'm going to distribute each to each. Actually, I take that back. I need to be clever before I start distributing. This just jumped out at me. We've got the sine of negative x. And if we look back here, remember, sine is an odd function. So the sine of negative theta is the same thing as the negative sine of theta. So I'm going to go back here, and I'm going to replace the sine of negative x with negative sine of x. So that's my first step. And then I'll distribute 1 plus sine x times 1. So that whole sine of negative x changes to the negative sine of x because it's an odd function. Now I'm going to distribute. And I'm going to distribute here, 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 and here, each to each. Okay, 1 times 1 is 1. 1 times the negative sine of x is negative sine x. Sine of x times 1 is positive sine x. And positive sine x times negative sine x is negative sine squared x. Remember, I'm trying to move to cosine squared of x, so something's got to happen for me here. Well, I've got opposites right here, so those drop out. They're a 0 pair. And that leaves me with 1 minus sine squared x. We'll go back here. This first Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Well, if I subtract sine squared theta off of both sides, I've got that the cosine squared of theta equals 1 minus sine squared theta. So that's the cleverness I'm going to use here. 1 minus sine squared of x, well, that's the same exact thing as cosine squared x. Done. All right, let's look at this next one. Secant squared theta minus 1 over secant squared theta. And I'm trying to see if I can get this big mess over here to equal out to sine squared theta. Well, the secant is reciprocal cosine. So I'm going to turn this into 1 over cosine squared theta minus 1 divided by, okay, in the bottom I've also got secant squared theta, so that's the same thing as 1 over cosine squared theta. Well, to add those fractions in the numerator, I've got to have a common denominator. So that's a 1 over 1. I need to multiply by my clever form of 1, cosine squared theta over cosine squared theta to get a common denominator. So here's where I am. 1 over cosine squared theta minus cosine squared theta over cosine squared theta, and that's big divided by 1 over cosine squared theta. All right, in my numerator now, perfectly legal for me to combine my numerators. Hopefully bells and whistles are going off in your head about what I just circled there. I can combine my numerators over my common denominator, and I get 1 minus cosine squared theta over cosine squared theta, big divided by 1 over cosine squared theta. Okay, the bells and whistles that should be going off in your head is that 1 minus the cosine squared theta, it's the exact opposite of what I did right here. So since 1 minus the sine squared of theta is equal to cosine squared theta from that Pythagorean identity, 1 minus cosine squared theta is sine squared theta. So this whole numerator right here becomes sine squared theta. Now I have sine squared theta divided by cosine squared theta, big divided by 1 over cosine squared theta. I never divide fractions. I multiply by the reciprocal. So this is the same thing as sine squared theta over cosine squared theta multiplied by that reciprocal cosine squared theta over 1. Multiply fractions straight across, so I've got common factors in the numerator and denominator, and that brings me to exactly what we were trying to show, that that whole thing is equal to sine squared theta. All right, gentlemen, how was that for you? All right. All right, now we're showing cotangent theta over the cosecant theta. Somehow we've got to finagle that to get it to look like cosine of theta. Okay, so cotangent is inverse or reciprocal tangent, and tangent, sine over cosine, so cosine or cotangent is cosine theta over sine theta, and that's divided by cosecant, and cosecant is reciprocal sine. So that's 1 over sine theta. Okay? I never divide fractions. I multiply by the reciprocal. Cosine theta over sine theta times the reciprocal sine theta over 1. My sine thetas divide out, and I'm left with, sure enough, cosine theta. These are kind of fun. Fun in my nerdy world, that is. It's almost like a puzzle. You're trying to figure out the pieces that rearrange and fit together. So hopefully these aren't too stressful for you. All right, for this next one, we want to start out with 2 times the tangent of theta times the secant of theta, and rewrite this thing so that all it has in it is sines. Okay? So, our first step, this is the same thing as 2 times. Okay, tangent is sine over cosine, so sine theta over cosine theta, and secant is reciprocal cosine, so that's 1 over cosine theta. All right, so far, and that's a 2 over 1, just to keep everything looking fractioning. So in my numerator, I have 2 sine theta over cosine squared theta. And remember, I'm trying to get everything in terms of sine. Well, from my original Pythagorean identity, I know that cosine squared theta is the same thing. Let me get a different color here. This cosine squared theta, I can use my Pythagorean identity and state that's the same thing as 1 minus sine squared theta. Everything's in terms of sine. That's all I have to do. Ready to move forward? They do get trickier, I promise. I know y'all are wanting them to get trickier. You want to be challenged, right? Okay. Here's where they start getting trickier. Okay, Josh wants to be challenged. I saw that, Josh. Okay, so we start here with sine squared of negative theta. So whenever you're plugging in a negative theta, just start thinking, okay, is this even or odd? What is this going to be equivalent to? Minus cosine squared of negative theta all over sine of negative theta minus cosine of negative theta. And we're trying to show that that's going to be equal to cosine theta minus sine theta. So I am going to use my even-odd identities. So sine is an odd function. The sine of negative theta is the same thing as negative sine theta, that thing's squared, because it's squared right here. Okay? And I'm subtracting. Okay. Cosine is an even function. So the cosine of negative theta is the same exact thing as cosine theta. So that turns into cosine theta squared. Okay? And I'm dividing that by, where's the theta right there? All right. Sine of negative theta, we know that that is negative sine theta minus cosine of negative theta is just cosine theta. All right. So when I square a negative, let me get a different color here. When I square a negative value, that thing's going to come out positive. So that term right there ends up being simply sine squared theta. And I am subtracting cosine squared theta. Bells and whistles. Oh, actually, that's not a Pythagorean identity because it's subtraction. Let me go back. You have to be even more clever with this one. So our Pythagorean identity is sine squared theta plus cosine squared theta equals 1. This is super clever here. You got to know your factoring for this particular section. And I'll tell you in a minute why. Okay, all I'm going to do with the denominator, I don't like having those two negative terms in the denominator, so I'm just going to factor out a -1 and call that sine theta plus cosine theta. Okay? So, think way back to your factoring properties. This thing right here is a difference of squares. Difference of squares is something in the form of a squared minus b squared. Those things always factor as a plus b times a minus b. So I can turn that entire numerator into sine theta plus cosine theta times sine theta minus cosine theta. Eek, your factoring days are not behind you yet. And so my denominator is -1 times sine theta plus cosine theta. And I'm sure you can see where I'm going with this now. My sine theta plus cosine theta is now a common factor to the numerator and denominator. And I'm dividing by a -1, so that just changes the sign of what I have left in my numerator. So now I have negative sine theta plus cosine theta. And if I flip-flop those terms, I have cosine theta minus sine theta, which is exactly what I was trying to show. Do y'all have any questions about that one? Okay, Josh, I see you're typing something. You love it. Oh, that makes my heart sing, Josh. Like I said, it's like a puzzle. Yeah, I enjoy these too. All right. This next one's even nastier for you, Josh. All right, let me just give myself a little barrier here because I'm going to need some room for this one. All right, sine squared theta minus 1 divided by tangent theta times the sine of theta minus the tangent of theta. And we're going to try to show that that thing is equal to sine theta plus 1 over tangent theta. So, let me get a different color here. This numerator right here is a difference of squares. Sine theta squared minus 1 squared. So that entire numerator translates to sine theta plus 1 sine theta minus 1, which is exciting because my sine theta plus 1 is already showing up in my numerator. So I know I'm on the right track here. Divided by, okay, tangent is sine over cosine. So sine theta over cosine theta. And then I just have sine theta, so I'm going to leave that. Sine theta, and that's over 1, just to keep it all fractiony looking. And I'm subtracting tangent theta, so that's also sine theta over cosine theta. Okay? So my numerator, sine theta plus 1, hopefully that'll travel all the way down with me, and everything else will go away in the numerator. Sine theta minus 1 divided by, okay, so I already have a common denominator in my denominator. So I can combine my numerators over my common denominator of cosine theta. So I've got sine theta times sine theta, which is sine squared theta minus the sine of theta, and that's over my common denominator of cosine theta. All right. Well, hopefully it jumps out at you that I have a common factor of sine theta in the numerator of my denominator. I know that language is a little confusing, but I hope y'all are following. So I'm going to factor sine theta out. So here's my big numerator, sine theta plus 1 sine theta minus 1, and that is divided by, let me get my pink to show my factoring here. I'm going to factor out sine theta, and when I do so, I'm left with sine theta minus 1. There's something that may help me get somewhere, and that's divided by cosine theta. All right, so I never divide fractions. I multiply by the reciprocal. So my numerator is sine theta plus 1 times sine theta minus 1, and that's over an understood 1, and I'm going to multiply by the reciprocal of my denominator, which is cosine theta over sine theta times sine theta minus 1. Okay, so since I'm multiplying everything across, I can divide out my common factors of sine theta minus 1 and sine theta minus 1. So here's what I'm left with. I'm getting there. Sine theta plus 1 times cosine theta over sine theta. Okay. Cosine theta over sine theta is tangent theta. I'm sorry, it's cotangent theta. But I'm trying to get to tangent theta. So, multiplying by a factor is the same thing as dividing by its reciprocal. Just like dividing by a factor is the same thing as multiplying by its reciprocal. Ken, I see you're typing. I'm going to stop here. Okay, great. All right, so just like when I pull my magic here and I turn this whole thing into multiplying by the reciprocal of the denominator, I can work backwards and say, well, if I'm multiplying by this thing, I can flip-flop that thing and divide by it. So, this is the same thing as sine theta plus 1 divided by the reciprocal sine theta over cosine theta. Very clever there. Well, sine theta over cosine theta is tangent theta, so we've made it. Sine theta plus 1 divided by tangent theta. Woo! Green checker, red X-Men. 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 All right. Green checksmen. All right. Verify the identity. 1 minus cosine squared of x times 1 plus cotangent squared x. All that business is supposed to equal 1. First thing I'm going to do is distribute. Well, I didn't go at it like this when I was working through this earlier, but it just dawned on me. 1 minus the cosine of theta, cosine squared of x, actually, that's sine squared x. Let me see if that would have been an easier way to get there. I think it might have been. Goodness, the way I went at it, I filled up the page. That's why I gave it a whole page by itself. Let me go back and look at my my Pythagorean identities. It's 1 plus the cotangent squared of theta. 1 plus the cotangent squared of theta is cosecant squared theta. I think I'm going to take another root than the one I did, because here we know 1 minus cosine squared theta is equal to sine squared theta. And we know that 1 plus the cotangent of theta is equal to the cosecant squared of theta. So I'm going to do this a different way. It might not take so much time and room. Unless y'all want to go the painful route, I'm happy to make it painful on you. I think this is going to be a lot easier than what I did. Holy cow. I wish I could take a picture and post it to the whiteboard here of all the work I went through to get to 1. Okay, 1 minus cosine squared theta. Josh has Eureka, exactly. That's why I say sometimes it just depends on you being clever about these things. Okay, 1 minus cosine squared of theta, that whole thing is sine squared x. I keep saying theta, sorry, it's x. And 1 plus cotangent squared theta that was cosecant squared, right? Yep, cosecant squared theta. Or cosecant squared x. Okay, so this could blow up in my face. I don't think it's going to. So I have sine squared of x. That, and I'm trying to get to 1. So sine squared of x. Okay, cosecant is reciprocal sine. I'm there. I'm so there. Oh my gosh, guys, y'all would not even believe this. I feel like taking a picture, sending it to myself, and putting it on the whiteboard for you. This is 1 over sine squared of x. Your sine squared of x is divide out, and you're left with 1. Done. Ah, oh my goodness. Let me see if I can get a picture onto the whiteboard of this for you. Y'all are going to be like, oh my gosh, Miss Gore, you tortured yourself there. I tend to make things harder than they really are. Let's see. I think y'all will get a kick out of this. And it'll give you another way of looking at it too. If I can get this to me here. Let's see. Okay, and let me grab that picture. And it should show up on my messenger on my laptop here in a moment. Oh my, I cannot believe what I went through. Oh my goodness. Give me just a moment. It's hard to make waiting seem interesting. All right, I'll go ahead and go forward, and then when it comes through, I'll go back and put it up there for y'all, because we do have a couple more to get through. We have 4 more to get through. And none of them are as bad as what I made that last one out as. Okay, so we have 2 times cosine, there it is, cosine theta plus cosine theta minus 1. This is where we get into remembering how to factor. Okay, so it showed up. Let me see if I can copy it and put it on the whiteboard for you. Oh my goodness. See, copy. Let's go back. Please paste. I want them to have a nice chuckle. I got it. I got it to work. It was just very painful. Okay, so let me point something out. Let's see, let me take the big smiley face off of there so it's not in the way. Okay, so this right here is not part of the problem. That's part of the one above. I went through all of that. Look at that nastiness right there to get to 1. And it did not even dawn on me that 1 minus cosine squared of x was sine squared of x. Yes, ouch, yes. It was painful, but it worked. And, you know, it's actually good that we stumbled upon this, because This just goes to show that everything that you do in mathematics has to complement other ways of doing that same thing. It all has to work. You see this a lot with your exponent rules. Because a lot of times with your exponent rules, it's just what you see first. Because there may be different ways of going about it, but they all have to work, or else mathematics is not the basis of pattern of life, and then we all just internally combust. So, yeah, there we go. That's what Ms. Gore went through, painstakingly preparing for this lesson. All right, let's get back to this. Okay, so we are asked to use algebra to turn this expression into an algebraic expression. And the first thing that I noticed is that this is in the form of a quadratic trinomial, like 2x squared plus x minus 1 if my x is equal to cosine theta. Now, we're not asked to factor this thing, but they do. So I'll just go through factoring. So the first thing I want to do is I want to say, okay, my x is equaling cosine theta. So now I have 2x squared plus x minus 1. That's an algebraic expression, but like I said, they took it all the way down to factoring it, and it can't hurt to recall this factoring technique, which is the AC method. So to factor a quadratic trinomial, I multiply A times C, and that gives me -2. And then I look for the factors, so what multiplies to make -2, but adds to make B. B is understood 1 in that case. And that is 2 and -1. My next step is to rewrite the trinomial, busting up the BX term using those factors that I found. So I have 2x squared. I'm not going to write plus 1x. I'm going to use those factors and say that's the same thing as plus 2x minus understood 1x, and then minus 1 on the end there. So 2x minus 1x is 1x, so I haven't changed this thing, I've just written it in a different form. And then I split it in half. I take the GCF of the first two terms, which is 2x, and that leaves me with x plus 1. I go to the other side, I take the GCF of the other two. Remember, you never want a negative leading term there, so I'm going to take out a -1 to make that leading term positive, so that's x plus 1. Now I have a common factor of x plus 1, and my leftover, when I divide that common factor out, is 2x minus 1. That's all they wanted you to do, was recognize that this thing is actually in the form of a quadratic trinomial, and you can use substitution to make it look more like what you're used to seeing. So this is warming you up, or warming you back up to substituting. This one here, this is a difference of squares. I can put it in the form of something squared minus something squared. And my somethings are 2 cosine theta and 1. Since I can fit it into that difference of squares mold, this thing factors as 2 cosine theta plus 1, 2 cosine theta minus 1. That's it. Last two problems. Okay, so I start out with cosecant squared theta minus cotangent squared theta. This is also a difference of squares, but that's not how I went about working with this one. I turned these into sine and cosine to start out with. Cosecant is reciprocal sine, 1 over sine squared theta. Cotangent is reciprocal tangent. Tangent is sine over cosine. So cotangent is cosine over sine, and they're squared. Okay? I've already got a common denominator, so I can easily combine my numerators over my common denominator. 1 minus cosine squared theta, bells and whistles, over sine squared theta. 1 minus cosine squared theta, according to my Pythagorean identity, is sine squared theta. And that's divided by sine squared theta. That's just 1. That whole thing equals 1. Last one. Okay, so I'm trying to show that cosine theta over 1 plus sine theta, that is not your Pythagorean identity down there. I'm trying to show that all that is equal to 1 minus sine of theta over the cosine of theta. Okay, so in the book they actually give you a hint. This is not something that you would have intuitively done. So anytime it's not really intuitive, they're going to give you a hint. And what they say is multiply by 1 in the form of 1 minus sine theta over 1 minus sine theta. So I'm just multiplying by 1. I'm not changing that thing. I'm just making it look different. So I have distribution here and here, and I've got distribution here, 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 and here. So that's what I'm going to do. This is cosine theta minus sine theta cosine theta over 1 times 1 is 1. 1 times negative sine of theta is negative sine theta. Sine theta times 1 is positive sine theta. Sine theta times negative sine theta is negative sine squared theta. My, pardon me, my opposites drop out there. And I've got a common factor of cosine theta in the numerator. So I'm going to factor out that common factor. Jesse, I'm finishing up my lecture, and the program won't let my video close out until everybody's out of the room. So can you meet me back in here in about 5 minutes? I'm on my last problem. Unless you want to learn a little bit of trig. Okay, I'll see you back here at 8:35. Thank you, Jesse. All right, cosine theta is my common factor. That leaves me with 1 minus sine theta. That's something I need in my numerator. And then my denominator is 1 minus sine squared theta. There's a Pythagorean identity right there. So I've got cosine theta times 1 minus sine theta over 1 minus sine squared theta is cosine squared theta. So in my numerator, I've got cosine theta times 1 minus sine theta over, I'm going to rewrite cosine squared theta as cosine theta times cosine theta. That's its definition there. Squaring something, multiplying it by itself. Divide out my cosine thetas, and I end up with what I was trying to show right there. 1 minus sine theta divided by cosine theta. That's all I have for you tonight. I hope that was helpful. And I appreciate y'all's attendance tonight. Y'all have a wonderful evening. You're very welcome, Josh. Thanks for coming. Thank you for coming as well.